No, I'm just going to make a little video, a little highlight reel of what we learned last week, okay? So last week we started our journey in C++. What is C++? C++ is just basically a set of rules, a set of language rules that allows you to get the computer to do things that you want to do. You type those rules in English, the computer turns them into ones and zeros, and it does that through the use of a compiler. Okay, there's lots of different C++ compilers. The one we're using is the free one. That's based off the one that comes with Linux. Linux operating systems. So I'm going to call this project Recap. You don't have to make it. There's the compiler we use. Look at how many you can use. There's a lot there. There's even a Microsoft one. But, okay, I'm using that compiler. It's just going to turn my words into, my English words into ones and zeros and allow me to control the computer. Is CodeBlocks a compiler, the environment we're working in? No, it's just an environment that allows us to type our code nicely and color it and have a nice play button to compile it. You actually don't need an environment like this. You can do it all in Notepad if you want and compile it on the command line. It's not hard to do. However, this is just a convenience for us as CodeBlocks. So what we learned introductorily last week is that when you press F9, it runs your code for you. It opens a little console window. Okay. And we learned how to output things to the screen with cout. Okay. What else did we learn? We learned how to make variables to store information in the computer. So I'm going to make a variable called A. All right. I can stop my code here. We haven't learned how to do this yet, but I'm going to hit play, and you'll see that it makes a spot in memory for a variable called A under watches. Has it done it? Yeah. Let me just click on that one more time. Going to go to watches here, and you can see, oh, I don't even see my variable. That's interesting. I wonder why. Very, very strange. I'm confused. Oh well. Let me try that one more time. Boom. Where are you, A? I made you. Show yourself. Optimized output. Okay. I wonder if I have some weird feature set out here. Alright, so integers will hold integer whole numbers. You can make them decimal numbers. Remember, C++ kind of allows you to get away with a lot of stuff, but it will give you undesired results. I'm going to make that 56. I'm going to make float B, which holds decimals. I'll make it pi, something like that. Okay. Decimal variable. This one is an integer variable. Integer variable. You can mix and match them and do math with them. The other one we learned was char. That's a character variable. It holds one letter or one symbol from your keyboard. Single quotes. Character variable. Used very rarely. Okay, but it's good to know it in case you see it. And then the string variable as well can hold all entire words. Yes, okay. Words. And those have to be in double quotes. Word variable, I guess. Okay, great. We also learned that you can ask the user to type in a variable. So let me make another variable here called string E. Cout. Enter. Oops. Enter a word. Okay. And when I do that, I write the word CIN, and if I put my variable there, it will cue the user to type that word in. Let's try that. Enter a word. Okay? Fred. There you go. Let's see if I stop my program, if I can watch my variables. Enter a word. Fred. My program is stopped here. There they all are. See that? here's something interesting that you might notice, and why C++, a good example of why C++ has a different variable type for integers and floats. Have a look here. A is 56, correct? Look what B is. 1.340001. That's not what I made it. I made it 3.14. What happened? Well, the computer is really good at changing integer numbers into ones and zeros, okay, through this binary system, but it's not as good at converting decimal numbers to ones and zeros because of this decimal. So what happened is it tries its best to convert it to ones and zeros, and then when it converts it back, there's a little bit of precision loss there. And look, I mean, we're off by 1/100th of a thousandth of a digit, but that could be important in banking or something like that, right? So the computer is not entirely accurate at converting decimal numbers into binary. My number C is R. Apparently R is the number 114 on that ASCII chart. We talked about that a little bit as well. Remember that ASCII table? It's the old school ASCII table here. And every number on it represents a button from an old style keyboard. So you can convert between characters and integers. Okay. So there's 255 of them. Or actually 256 of them. Yes.
Sorry to bite you.
No problem.
So I got them to do that Google form thing about like their.
So we got our 5 variables there. That's basically all we've learned. One other important thing that we've learned is some math. Okay. Let me just zoom in quickly and show you how to do some math. See out. I'm just going to write some math here. 5 plus 7 times 9 and divided by 6. This will probably give me an integer answer, even though the answer may not necessarily be an integer. Why? Well, let's think about it. It's going to do the 7 times 9 first, so that's 63. Then it's going to divide by 6, which won't work. Like, it won't be a whole number, right? It'll be 10 point something, and then plus 5. So I should get like 15 point something. Let me see if it does that.
But for all we know, since it adds like the 0.0001, that could change to a whole number.
Well,
Math works that way.
I don't know. Look, it says 15, okay? The reason why it spits out an integer, even though the answer isn't an integer, is because all 4 numbers are integers there. If I put 6.0, Mohammed, watch. All I do is change one of them to a float. It actually gives me the real answer, okay? So it will chop off decimals if all of your numbers are integers. It won't round it. Shouldn't it have rounded it to 16? Theoretically, yes. But C++ doesn't know what rounding is. It doesn't know that humans round numbers if they're bigger than 0.5. Okay? It's a computer.
You set it to do that?
Can you set it to round? There's a function, there's a command called round in the math, I think, if you include. So we also talked about this too, right? Where like you don't include every single command that comes with the C++ compiler because there's a million of them, right? You include only the ones you want, and most of the time, like if I type the letter A, look at this is all the libraries that start with the letter A. There's all the ones that start with B. I can keep going. Like there's so many, right? So the ones we almost always use are just this one, input output stream and math. But there is a command called round, I think. Like if I go cout round, yeah, there it is. And I write 15.7, I think that will put 16 on the screen. Okay, or you could write your own command to do that. Later on, we'll see how to do that. It does write 16 on the screen. Okay, so that's this is called a function in C++, not to be confused with a math function. They work very much similar. And I know you guys have probably just started grade 11 functions and haven't really gotten into what a function does in math. Another example of a function is square root. Okay? And the square root of 18. I don't know what that is, but I'm going to guess it is a number between 4 and 5. Let's check it out. It is 4.24264. Okay. Here's another important thing we learned that we won't use till later, but the remainder button. Okay. Let's say I take the number 17 and I divide it by 3. If I divide it by 3, it's going to give me what? It should be like a number between 5 and 6, right? That make sense? But it's actually going to spit out the number 5 because it's 2 integers. Okay. However, there is a button, a command that will give you the remainder. Okay. This answer is going to be 2. Convince yourself that 17 divided by 3 has a remainder of 2. Why? Okay. Why does it have a remainder of 2? Let me go and take my calculator and go 17 divided by 3. Okay, the actual answer, whoa, I'm on the programmer calculator. It knows. So 17 divided by 3 is 5.666667. Okay. However, it goes in 5 times. What's 5 times 3? 15, right? So how many do I have left over from 17? I have 2 left over. Remainder. Okay. What's the answer? Does it say 2? Yeah, it says 2. Okay. So that's all the highlights of what we learned last week. We're going to have a test on labs 1, 2, and 3. Okay, so make sure you know what went on in those labs. I marked them all. Assignment, keep working on that if you're not done. Boolean variables as well, work on that today. And maybe that's all we'll do today is just work on the assignment and lab 4, okay? And we'll have a test tomorrow. What does the test look like? The test looks like, let me pull it up here.